For as long as humanity has looked upward, there has been a question written in the sky. A pale river of light stretched across the heavens, soft, unbroken, eternal. The ancients called it the path of gods, the milk of creation, the road of souls. To them it was not just light, it was meaning, mystery, destiny itself. Centuries later, the river still shines. But the question remains, what is the Milky Way? Is it a boundary, a home, a structure we can define, or is it something greater, so vast that every attempt to measure it reveals only how little we truly know? For generations, astronomers believed they could capture its form, sketch its outline, weigh its stars. They built maps, counted clusters, traced spirals. They thought they had found its edges, but again and again those edges dissolved, slipping away into shadows of unseen matter, into streams of stars unraveling at its borders, into halos of gas and dark mass stretching farther than imagination dared. The Milky Way is not the galaxy we once believed it to be. It is larger, more complex, and infinitely more mysterious. What we see with our eyes is only the faintest glow at its center. Its true body lies hidden, invisible, sprawling, unfinished. And so begins the story of discovery. A story of how myths gave way to telescopes, how debates fractured the meaning of the universe itself, and how one revelation changed our place in the cosmos forever.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
For most of human history, the Milky Way was not a galaxy at all. It was a river, a celestial scar across the heavens. In Greek mythology, it was the milk of Hera spilled across the night sky, eternal and luminous. To the Maya, it was the road of souls, the path the dead followed into the afterlife. In the stories of countless cultures, it was a band of light, sacred and unbroken, stretching beyond comprehension. But behind myth, there was mystery. What was this pale arch that seemed to envelop the earth? A cloud, a fire, or something far more profound? The first step toward unraveling that mystery came with a simple tool, a telescope. In 1610, Galileo Galilei turned his refractor to the Milky Way and saw not mist but multitudes, thousands upon thousands of stars packed so tightly together that the human eye could not distinguish them. The veil was pierced. The universe was no longer an unbroken canvas of divine light. It was structure. It was depth. In the centuries that followed, astronomers tried to measure and map this stellar ocean. William Herschel, in the late 18th century, attempted to chart the Milky Way by counting stars in every direction. His conclusion was radical for its time. The stars formed a flattened disk, and the sun was somewhere near its center. Though crude and limited, it was the first attempt to give the Milky Way shape. Yet as the 20th century dawned, a great debate raged. The question was deceptively simple. What is the universe? Was the Milky Way the entirety of existence, containing all the stars ever to be seen? Or were the faint, fuzzy spirals captured by telescopes, spiral nebulae, other island universes, galaxies like our own drifting in an infinite sea? The debate reached its climax in 1920 at the Smithsonian, where astronomers Harlow Shapley and Heber Curtis faced off in what became known as the Great Debate. Shapley argued that the Milky Way was vast enough to encompass all observed nebulae. Curtis countered that these nebulae were separate galaxies altogether, far beyond the borders of our own. For a time, the universe seemed to balance on the outcome of their words. The answer came not in a lecture hall, but in the sky above Mount Wilson. There, Edwin Hubble used the newly built 100-inch Hooker telescope to study the Andromeda Nebula. Within its faint glow, he identified Cepheid variable stars, celestial beacons whose rhythmic pulses revealed their distances with mathematical precision. The result was astonishing. Andromeda was not a nearby cloud within the Milky Way. It was an entire galaxy in its own right, millions of light years away. The universe had cracked open. The Milky Way was no longer the universe. It was one among many. And suddenly the question shifted. If this was just one galaxy, what was its true size? Where did its edges lie? The pursuit of that answer unfolded across the 20th century like a cartographer's dream. Astronomers began to map the Milky Way, not by counting stars, but by using physics as their compass. Henrietta Leavitt's work on Cepheids allowed astronomers to measure stellar distances. Star by star, arm by arm, the Milky Way's skeleton emerged. By mid-century, radio astronomy offered a new set of eyes. Dust that had blinded optical telescopes no longer hid the galaxy's heart. Hydrogen's 21-centimeter line emission revealed the spiral structure of the Milky Way with unprecedented clarity. For the first time, astronomers traced its arms, curling out like immense galactic rivers. And yet, every new discovery only stretched the Milky Way further. The stellar disk extended tens of thousands of light years. The spiral arms wrapped around in delicate arcs. Globular clusters, spherical swarms of ancient stars, circled the galaxy's periphery like loyal sentinels, suggesting that the Milky Way was not a flat wheel, but a vast three-dimensional structure. By the late 20th century, the picture grew stranger still. Astronomers identified stellar streams, ghostly ribbons of stars stretching across the halo. They were the remnants of smaller galaxies torn apart and devoured by the Milky Way's gravity. This was not a static system. It was alive, cannibalizing, reshaping, expanding. But the most unsettling revelation came from something that could not be seen at all. When astronomers measured the motions of stars and gas in the galaxy, the numbers defied expectation. The visible mass of stars and gas was not enough to account for the gravitational pull holding the galaxy together. The outer stars were moving far faster than Newtonian mechanics would predict. The invisible culprit was named dark matter, a mysterious substance, unseen and undetectable by ordinary light, yet outweighing all the stars combined. Its gravitational influence stretched the Milky Way far beyond the reach of its visible arms. What we once believed to be a luminous island was only the glowing heart of a far larger, shadowy empire. Today, astronomers estimate that the Milky Way spans more than 100,000 light-years across invisible stars, and perhaps over 1 million light-years when the invisible halo of dark matter is included. Our galaxy is not a flat spiral with neat borders. It is a sprawling, ever-shifting domain of luminous streams, ancient clusters, and unseen matter, stretching into the depths of intergalactic space. The discovery phase is not over. With each new survey, from the Sloan Digital Sky Survey S-mapping of stellar streams to Gaia S-billion-star census, the Milky Way grows larger, more complex, and more enigmatic. The river of light that once seemed a narrow band across the night sky has revealed itself as something vast, turbulent, and unfinished. A structure so immense that it challenges not only measurement but imagination. The Milky Way, it seems, is bigger than we thought. For centuries, the Milky Way had been drawn like a map, a disk of stars, a spiral of light, a defined home in the dark. But in science, definitions rarely hold for long. Every time astronomers thought they had captured the size of our galaxy, new evidence arrived to tear the frame apart. The first shock came not from theory, but from the sky itself. In the late 20th century, deep surveys revealed faint structures stretching beyond the known spiral arms, vast arcs and ghostly rivers of stars crossing the galactic halo. One of the most striking was the discovery of the Sagittarius dwarf galaxy, a small companion caught in the Milky Way's gravitational grip. As it fell apart, its stars stretched into immense tidal streams, wrapping around the galaxy like torn silk. Suddenly, the neat edge of the Milky Way dissolved. Our galaxy was not a closed disk. It was bleeding into space, consuming and scattering matter far beyond what telescopes had drawn. Then came the realization of the warp. Radio observations showed that the Milky Way's disk was not flat at all. Instead, its edges twisted and bent like a warped vinyl record, arcing thousands of light-years above and below the galactic plane. The stars at the rim did not lie neatly along the spiral. They curved, swayed, and carried evidence of past collisions. The Milky Way was not a pristine structure. It was scarred, distorted, and still in motion. But the true shock lay hidden in the motions of stars. Astronomers measured the speed of stars orbiting the galaxy, expecting them to follow Newton's law of gravitation, slower at the edges, faster near the center. What they found instead was defiance. Stars at the outer rim were moving far too fast. The luminous matter of the Milky Way simply could not hold them. By all visible accounts, they should have been flung into intergalactic space, yet they remained bound, orbiting faithfully, as if held by an unseen hand. This invisible mass, exerting its silent gravity, was named dark matter. The revelation was devastating. The Milky Way was not composed primarily of stars, gas, and dust. In fact, everything we see, the hundreds of billions of stars, the glowing nebulae, the luminous spiral arms, accounted for only a fraction of its true mass. The rest was hidden, untouchable, and unknown. The shock deepened with the Sloan Digital Sky Survey at the turn of the millennium. Its panoramic mapping of the sky uncovered more than streams and clusters. It revealed entire stellar structures far beyond the galaxy's edge. The halo of the Milky Way was not sparse and empty. It was rich, teeming with remnants of devoured galaxies, faint star clouds, and overlapping rivers of cosmic debris. Each discovery pushed the boundaries of the galaxy outward until the concept of a sharp edge felt meaningless. Then came Gaia. Launched by the European Space Agency in 2013, Gaia measured the positions and motions of more than 1 billion stars with exquisite precision. What it revealed was staggering. Stars once thought to be confined to the disk were shown to travel in vast arcs through the halo, tracing the outlines of ancient galactic mergers. Entire populations of stars, such as those belonging to the Gaia Sausage Enceladus remnant, were identified as the fossil remains of galaxies long since absorbed into the Milky Way. The galaxy's size, mass, and history all had to be rewritten. The shock was not only numerical, it was emotional. For the first time, astronomers realized that humanity lived not in a serene island galaxy, but in the aftermath of countless collisions. The Milky Way was scarred by its past, larger than imagined, and still growing by consuming its neighbors. Even more unsettling was the implication of dark matter's halo. While the visible Milky Way spans roughly 100,000 light-years, its gravitational influence extends 10 times farther. The halo of unseen matter stretches perhaps 1 million light-years into intergalactic space, overlapping with the domain of the Andromeda Galaxy. In this invisible ocean, the very concept of our galaxy dissolves. Where does the Milky Way end? Where does Andromeda begin? Or are the two already part of a larger shared gravitational system, their halos interwoven, long before their visible disks collide? Each new discovery struck like a hammer against certainty. The warp, the streams, the halo. The realization that the luminous Milky Way, the one painted in textbooks and star atlases, was merely the glowing heart of something far more immense. The scientific community did not hide its astonishment. Headlines spoke of a galaxy twice as massive as thought, of structures larger than expected, of a hidden halo beyond the stars. The language itself betrayed the shock. Every estimate, every model, every careful attempt to define the Milky Way S-boundary was shattered by the immensity of what lay beyond. And so a new picture emerged. The Milky Way was not a static spiral, neatly outlined against the night. It was a dynamic, restless organism, warped, colliding, devouring, and expanding. Its edges were not edges at all, but tides, flows, and shadows of invisible matter. The shock of discovery was not merely scientific, it was existential. For if the galaxy that shelters humanity is larger and stranger than thought, what else have we underestimated? How many other truths about the universe remain hidden, waiting to overturn our maps, our models, and our sense of place? The Milky Way was no longer what it seemed, and the deeper astronomers looked, the more its boundaries dissolved into mystery. The discovery that the Milky Way was larger, stranger, and more restless than imagined was only the beginning. Shock opened the door, but true understanding required method. The galaxy could no longer be grasped by myth or metaphor. It had to be measured, star by star, cluster by cluster, stream by stream. Yet this task was unlike charting an island or a continent. Humanity lives inside the Milky Way, embedded within its disk. Mapping it is like trying to sketch the shape of a forest while trapped beneath its canopy, with trees stretching endlessly in every direction. Perspective is our prison. The earliest efforts to break free of that prison came through parallax. By observing a star's position against the background sky at 2 points in Earth's orbit, astronomers could measure its distance. For nearby stars, this geometric method was exquisite, but for the vast scale of the galaxy, it was painfully limited. Beyond a few hundred light-years, the angles became too small, vanishing into uncertainty. So astronomers turned to light itself. Cepheid variables, pulsating stars whose brightness waxes and wanes with precise regularity, became the galaxy's lighthouses. Their rhythms revealed their intrinsic brightness, which, compared with their apparent glow, yielded distance. With these beacons, astronomers charted not just the local stars, but the spiral arms themselves. Each cepheid was a marker on the Milky Way's map, a point of clarity in the dark. But even with cepheids, the picture remained incomplete. Dust clouds wound through the galaxy like fog, obscuring distant stars. In visible light, the disk seemed fractured and impenetrable. It was radio astronomy that cut through the veil. By tuning into the 21-centimeter wavelength emitted by neutral hydrogen, astronomers pierced the dust and revealed the skeleton of the Milky Way. Arm by arm, the galaxy's spiral structure came into focus. Still, this was only the visible disk. The deeper questions remained. How far did the Milky Way truly extend? What lay in its outskirts beyond the luminous spiral? The answers came not from the core, but from the edges. Globular clusters, ancient spherical gatherings of hundreds of thousands of stars, orbited the galaxy like lanterns at its border. Their positions and motions became critical markers of the Milky Way's reach. In the early 20th century, Harlow Shapley used globular clusters to demonstrate that the Sun was not at the center of the galaxy, but displaced by tens of thousands of light-years. Later generations of astronomers refined their distances, finding clusters far beyond the disk, suspended in the galactic halo. Each one was a boundary stone, pushing the known edges outward. Then came the stellar streams, torn remnants of devoured dwarf galaxies. These rivers of stars arced across the halo like cosmic scars: the Sagittarius Stream, the Orphan Stream, the Monoceros Ring. Each traced the gravitational contours of the Milky Way, revealing its mass and reach. By following their paths, astronomers discovered that the galaxy's influence stretched far beyond the visible stars. The halo was not empty space. It was a graveyard of galaxies. The investigation deepened further with the study of ultra-faint dwarf galaxies. These fragile companions, some containing only a few thousand stars, orbited at the edges of the Milky Way's domain. Their survival depended on the galaxy's gravity, marking the outer limits of its control. Yet, as more were discovered, faint smudges on deep sky surveys, it became clear that the Milky Way's grasp extended farther still. Many of these dwarfs were not just companions. They were captives, their orbits stretched and broken by the Milky Way's pull. Each method, parallax, Cepheids, radio mapping, globular clusters, stellar streams, dwarf galaxies, was a fragment of a larger puzzle. Together they outlined a galaxy whose size defied simplicity. The Milky Way was not a disk of 100,000 light-years. It was a layered structure, a bright core, spiral arms, a halo of clusters, streams of stars, and an invisible cocoon of dark matter. The boundary was not a line. It was a gradient, a fading influence stretching into intergalactic space, and the deeper astronomers looked, the more the picture blurred. For every precise measurement, there were uncertainties, distances skewed by dust, motions tangled by gravitational interactions, models distorted by assumptions. Even Gaia, with its billion-star catalogue, faced limits. The farther from the Sun, the harder it became to measure with accuracy. The outer halo remained ghostly, its dimensions inferred more than observed. Yet the investigation pressed on. Computer simulations offered a new vantage point. By recreating galaxies under the laws of physics, astronomers tested how the Milky Way should look if built from stars, gas, and dark matter. These simulations revealed a galaxy in constant flux, shaped by collisions and mergers, its halo swelling and contracting with the tides of cosmic history. The streams and clusters observed in the real sky matched these models, confirming that the Milky Way was not static, but dynamic, an evolving structure still sculpting itself in the present. The deeper investigation transformed the very concept of home. The Sun, once imagined as central, was revealed to orbit 27,000 light-years from the galactic core. The disk, once thought flat, was warped and twisted. The halo, once thought empty, was filled with stars and debris. The Milky Way was not a calm island. It was a restless empire, its boundaries defined not by order, but by motion and memory. And still, questions lingered. How massive was the dark matter halo? Was it spherical, elongated, or clumpy? How many dwarf galaxies lay hidden in its outskirts, too faint to see? Was the corona of hot gas surrounding the Milky Way a thin veil, or a vast reservoir stretching hundreds of thousands of light-years? Every answer revealed more questions. The galaxy grew, not just in size, but in mystery. And as astronomers measured, mapped, and modeled, they realized that the Milky Way's true form could never be captured in a single map. It was a story told across billions of stars, unfolding in time as well as space. The deeper they looked, the more the Milky Way slipped from definition. It was larger than imagined, more complex than expected, and still unfinished, still in the process of becoming. The deeper astronomers pressed into the structure of the Milky Way, the more its boundaries dissolved. What began as a luminous spiral of stars became something stranger, an organism swollen by invisible matter, distorted by collisions, and blurred at the edges where space itself seemed uncertain. At the heart of this escalation lies a presence that cannot be seen: dark matter. For decades, its fingerprints had haunted the galaxy's rotation curves, revealing that the Milky Way's stars were bound by something far heavier than themselves. But only when astronomers began to model its influence did the true scale emerge. The spiral disk, 100,000 light-years across, was dwarfed by an unseen halo perhaps 1,000,000 light-years wide. This ghostly cocoon outweighed the galaxy's luminous mass by a factor of 10. It meant the Milky Way was not what human eyes had ever perceived. The starlit spiral was only its glowing heart. The true galaxy was vast, invisible, and overlapping with its neighbors. In fact, the Milky Way's halo likely already touches that of Andromeda. Two galaxies, still separated by 2 million light-years in visible light, are already interwoven in the dark. But the mystery deepens further. Observations revealed that the Milky Way's disk is not flat. Its edges bend and warp, twisting like the rim of a great cosmic bowl. Stars at the far reaches rise thousands of light-years above the galactic plane, forming an undulating structure. Why? Some suspect collisions with satellite galaxies, their gravity tugging and distorting the disk. Others point to the pull of the Large Magellanic Cloud, a dwarf companion whose orbit could be dragging the Milky Way's outer rim into motion. Whatever the cause, the warp is a sign that the galaxy is not serene. It is restless, trembling under the influence of invisible hands. The corona added yet another layer of strangeness. Surrounding the Milky Way lies a vast reservoir of superheated gas, tenuous but immense, glowing faintly in X-ray light. This galactic corona stretches hundreds of thousands of light years, possibly accounting for much of the galaxy's missing baryonic matter, the ordinary matter not seen in stars or planets. If true, then the Milky Way is even larger, extending far beyond its stellar halo into an atmosphere of hot, thin plasma. We live not in a disk of stars, but in a layered structure of light, dark, and gas, merging into the intergalactic medium. Each discovery sharpened the paradox. The Milky Way grew bigger, but its edges grew blurrier. Where did it truly end? At the rim of the disk? At the farthest globular cluster? At the limits of the dark matter halo? Or did it have no end at all, only a fading influence, bleeding into the fabric of the cosmos? The mystery deepened, not only in size, but in time. Gaia's data revealed the galaxy's violent past. Mergers with galaxies like Gaia Enceladus, which plunged into the Milky Way billions of years ago, scattering stars across the halo. Other mergers are still unfolding. The Sagittarius dwarf galaxy is currently being torn apart. Its stars stretched into a ribbon around the Milky Way. The Magellanic Clouds too are in orbit, their gas streams feeding the galaxy, even as their own structures are unraveling. The Milky Way, it seemed, was not simply large. It was alive, growing through collision and consumption, reshaping itself with every encounter. Each dwarf galaxy captured, each tidal stream formed, each warping of the disk was evidence of an unfinished process. We were witnessing not the final form of our galaxy, but a single moment in its evolution. Even the future carried mystery. The approaching collision with Andromeda, set to occur 4 billion years from now, was no longer a distant speculation. Already, their halos interact. Already, their gravitational tides shape the motions of stars. The Milky Way's fate is sealed not as an isolated spiral, but as one half of a galactic union, destined to merge into a colossal elliptical galaxy. And if the Milky Way is larger than thought, then the scale of that merger is grander still, reshaping not just two galaxies, but the structure of the local group itself. As these revelations accumulated, a deeper truth emerged. The Milky Way could no longer be understood as a single, simple object. It was not a disk, not a spiral, not even a halo. It was a hierarchy of structures: disk, bulge, halo, streams, corona, and dark matter envelope, interacting across space and time. Each layer held new mysteries, each boundary dissolved under scrutiny. This was escalation not in violence, but in wonder. The more astronomers measured, the more immense the galaxy became. The more immense it became, the less its borders could be defined. And so the Milky Way transformed from a place to a process, from a picture to a story of collisions past and future, a story of invisible matter shaping luminous forms, a story of boundaries that recede with every discovery until the concept of size itself feels inadequate. The Milky Way is not merely bigger than we thought. It is deeper than we imagined, and the mystery has only begun. The Milky Way stands before us as both map and mirage. Measured in the light of stars, it seems finite, an island of perhaps 100,000 light-years across. Yet in the language of gravity, in the silent calculations of orbital speeds, it swells to dimensions an order of magnitude greater. At the heart of this paradox lie competing models, each a reflection of the struggle to grasp the galaxy's true size and mass. The earliest estimates of the Milky Way's mass relied on the motions of globular clusters. These ancient star systems orbiting the halo move at speeds that betray the weight of the galaxy's invisible hand. By applying Newton's laws, astronomers could calculate how much mass was required to hold them in orbit. The numbers were startling. The galaxy weighed hundreds of billions of solar masses, far more than the luminous stars could account for. With each refinement, the estimate grew until it reached 1 trillion solar masses or more, most of it unseen. But even now, disagreement persists. Some models suggest the Milky Way is on the lighter side of galactic giants, perhaps 600 billion solar masses. Others push the figure higher, 1.5 trillion suns or more. The uncertainty lies not in carelessness, but in complexity. The motions of stars, clusters, and streams are influenced not only by the galaxy's total weight, but by how that weight is distributed. Is the dark matter halo compact, concentrated near the disk? Or is it extended, stretching into the intergalactic void like a diffuse ocean? Each model paints a different picture, each bound by assumptions not yet tested. The shape of this halo is no less mysterious. For decades, many imagined it as spherical, a simple, invisible globe encasing the luminous spiral within. But as data accumulated, that vision blurred. The orbits of satellite galaxies and the paths of stellar streams suggested asymmetry. Some simulations pointed toward a triaxial halo, elongated in one direction, compressed in another, a distorted cocoon shaped by cosmic history. Others proposed irregularity, a clumpy halo where dark matter pools in substructures, echoing the debris of countless collisions. If true, the Milky Way is not wrapped in a perfect sphere, but in a shifting, fractured veil. Its boundaries are not smooth, but jagged. Its gravity is not uniform, but rippled. And the stars that sail through it, like those in the Sagittarius stream, carry in their motions the whispers of its hidden form. The speculation does not end with dark matter's geometry. Hidden structures may still lie within the galaxy itself. Astronomers have already discovered spiral arms that once eluded detection, their faint populations revealed only by deep radio and infrared surveys. Could there be more? Some models suggest that the Milky Way may harbor ghost arms, stellar streams so diffuse that they blend into the background, unrecognized as coherent structures. If so, the galaxy's architecture is incomplete, its skeleton still only partly revealed. Beyond the arms, there may be features even stranger. Tidal relics from past collisions, so stretched and diluted that they appear as little more than faint gradients of starlight, or undiscovered dwarf galaxies trapped deep within the halo, their faint stars hidden behind veils of dust or too scattered to distinguish from the galactic background. If such galaxies exist, they would not be anomalies, but expected guests. Cosmological models predict that a galaxy the size of the Milky Way should host dozens, perhaps hundreds, of small companions. Yet only a fraction have been found. The rest remain invisible, awaiting discovery by surveys of unprecedented depth. At the center of these speculations lies a question of identity. What is the Milky Way? Is it defined by the stars we see, the streams we trace, the halo we cannot touch? Or is it something more elusive, a gravitational domain, extending as far as its pull can reach, regardless of whether light fills the space? If so, the galaxy has no edge, only influence. Its size becomes not a number but a fading curve, a boundary written not in stars but in motion. The past offers its own clues. The Milky Way bears scars of cannibalism, and each one reshapes our understanding of its size. When the Gaia mission revealed the remnants of the Gaia Sausage Enceladus galaxy within our halo, it was clear that the Milky Way structure had been forged in collision. Its thick disk, its halo populations, even its dark matter distribution may all be products of ancient mergers. In swallowing smaller galaxies, the Milky Way grew, not just in stars, but in space itself. This cannibalism continues. The Sagittarius dwarf galaxy is being torn apart before our eyes, its stars spilling into streams that wrap around the galaxy. The Magellanic Clouds, once thought safe in orbit, are now known to be unstable, their mass and motion hinting that they too may one day dissolve into the halo. Each absorption changes the Milky Way's size, its weight, and its shape. Our galaxy is not a finished object, it is a process, an ongoing act of creation through destruction. If this is true, then the future of the Milky Way may be more dynamic than imagined. The scheduled collision with Andromeda 4 billion years hence is no longer a distant speculation, but a gravitational inevitability. Yet even this timeline is uncertain. If the Milky Way is more massive than thought, if its halo is larger, its pull stronger, then the encounter may occur earlier. Already the overlapping halos suggest that the two galaxies are not separate entities, but participants in a slow, inevitable dance. Their merger will not simply double their size. It will erase their identities, replacing them with a single colossal remnant. In contemplating these possibilities, the boundaries between science and philosophy blur. To misjudge the size of our own galaxy is not a minor error. It is a reminder of how limited human perception remains. If we struggle to measure the borders of the Milky Way, how much more elusive must be the universe itself? What structures lie beyond the horizon of light, hidden in darkness or drowned in distance? What truths remain unseen because our instruments, like our minds, are bound by perspective? Einstein's theory of general relativity adds another layer of depth. Space and time themselves are not fixed stages, but malleable, curved by mass. The motions of stars through the Milky Way are not mere orbits around a static center, but journeys through warped space-time. The shape of the dark matter halo, the distortions of tidal streams, even the coming collision with Andromeda, all unfold as choreography upon a curved cosmic fabric. To understand the galaxy is to understand not just stars and matter, but the geometry of reality itself. At the core of the Milky Way, this curvature is made manifest in Sagittarius A, the supermassive black hole 4 million times the mass of the Sun. Its gravity bends light itself, shaping the orbits of nearby stars into ellipses so tight that they dance within a single human lifetime. Stephen Hawking once reflected on black holes as the ultimate expression of mystery, objects where gravity overpowers all else, where information seems to vanish. The presence of such a singularity at the heart of our galaxy extends its influence far beyond the event horizon. The very stability of the Milky Way may be tied to its central black hole, anchoring stars in a gravitational domain that stretches outward across tens of thousands of light years. And if one black hole defines the core, could others, smaller, hidden, drifting in the halo, add their subtle pulls to the galaxy's mass? Some theories suggest populations of intermediate mass black holes, remnants of ancient mergers, may lurk unseen in the outskirts, their presence detectable only through faint distortions in stellar motions. If so, the Milky Way is not merely bigger in breadth, but in depth, layered with gravitational wells invisible to sight. As speculation deepens, the most profound possibility emerges, that the phrase "bigger than we thought" is itself only a threshold. For what if there is no true boundary at all? What if the Milky Way is not an object, but a node in a cosmic web, its edges dissolving into the filaments of dark matter that span the universe? In this view, the galaxy is not a finite island, but a condensation, one ripple among many in a sea with no shore. Its size becomes not a measure of stars, but a measure of connection. In confronting such ideas, wonder and humility intertwine. The Milky Way is not merely larger than imagined, it is a mirror, reflecting back the limits of human comprehension. Each attempt to define it peels away certainty, leaving behind not answers but horizons. Horizons that stretch into darkness. Horizons that remind us that in the face of the cosmos, every conclusion is but a beginning. Every measurement of the Milky Way tells a different story. One model frames it as a modest spiral, lighter than its neighbor Andromeda. Another places it among the giants, with 1 trillion solar masses anchoring its halo. The disagreement is not failure, but reflection. The galaxy is a puzzle whose pieces are still in motion. Astronomers test these models by following the orbits of satellite galaxies. The Magellanic Clouds circling like twin lanterns in the southern sky are not mere companions. They are test particles, their motions encoding the weight of the Milky Way's gravitational pull. If the Milky Way is light, the clouds may eventually drift away, independent travelers in the local group. If it is heavy, they are bound forever, destined to spiral inward and dissolve into its halo. Observations suggest the latter. Their gas streams trail across hundreds of thousands of light years, evidence of the Milky Way's tug. And yet, the precise figure, the exact mass of the galaxy, remains elusive. Beyond the Magellanic Clouds lies another mystery. The ultra-faint dwarfs. Some are so dim they contain fewer than 1,000 stars, yet they orbit within the Milky Way's sphere of influence. Their survival suggests a powerful gravitational field, but their scarcity is puzzling. Theoretical models predict far more dwarfs than are observed, a mismatch known as the missing satellites problem. Are these galaxies hidden by dust, their faint light lost to the background of stars? Or is dark matter distributed in ways yet unknown, suppressing their formation? Each possibility reshapes the Milky Way's portrait. Theories about the dark matter halo continue to multiply. If it is spherical, then the galaxy's mass flows outward smoothly, like a perfect sphere of gravity. If triaxial, it bends and warps, shaping the orbits of satellites into elongated paths. If clumpy, then the halo may be filled with invisible knots, subhalos of dark matter, relics of smaller galaxies consumed but not erased. Each possibility leaves signatures in the sky, distorted streams, misaligned clusters, faint anomalies in the motions of stars. Detecting them is not easy. It requires billions of data points, sifted through with patience and precision. Gaia's star catalogue has begun this work, but the answers remain hidden, waiting in the dance of orbits. And so speculation continues. Could the Milky Way be far more massive than believed, its halo stretching not 1 million but 2? If so, its influence would extend deep into the local group, binding not just its satellites, but even the motions of nearby galaxies. The Milky Way and Andromeda, then, are not isolated dancers approaching for the first time. They are already entwined, their halos merged into a single overlapping system. The local group itself may be less a collection of galaxies and more a single entity, a double-core giant whose collision has already begun. Speculation also turns inward, to hidden structures within the disk itself. Astronomers have uncovered stellar populations moving at odd angles, streams that do not align with the known spiral arms. Some are remnants of past mergers, fossil signatures embedded in the disk. Others may be new structures altogether, subtle arms, broken arcs, or incomplete spirals. What we call the Milky Way's 4 arms may be an oversimplification. Its true architecture could be a web of streams and arcs, some luminous, some ghostly, all shifting with time. The possibility of undiscovered dwarf galaxies hiding within the halo adds to the intrigue. Already, telescopes like Pan-STARRS and the Dark Energy Survey have uncovered faint companions, their stars barely distinguishable from the cosmic background. Each new discovery pushes the count higher, hinting that many more remain unseen. If so, the Milky Way may be surrounded by a swarm of satellites, too faint for the naked eye but crucial in shaping its history. This idea connects to a broader truth. The Milky Way is not static, but sculpted by its cannibalism. Each merger leaves fingerprints. Gaia revealed one of the largest, the Gaia Sausage Enceladus event, a galaxy swallowed billions of years ago. Its stars now form a distinctive population in the halo, their motions unlike those born in the Milky Way. Other mergers are smaller, but no less telling. The Sagittarius dwarf, still unraveling, wraps the galaxy in ribbons of stars. Each captured galaxy adds not just to the Milky Way's mass, but to its complexity. Its thick disk, its warped edges, even its chemical composition, all are shaped by the violence of these encounters. Speculation stretches forward as well as backward. If the Milky Way's halo is larger and heavier than expected, the timeline for its future collision with Andromeda could shift. Instead of 4 billion years, the first interactions may occur sooner, their halos already exchanging matter. The event will not be sudden but slow, a drawn-out merging over billions of years. Spiral arms will twist and tear, stars will scatter into tidal tails, and the two black holes at their centers will spiral together, merging in a cataclysm of gravitational waves. The result will be an elliptical galaxy, swollen and luminous, a remnant larger than either progenitor. And if the Milky Way is bigger than thought, then the scale of this collision is grander still. An event that will reshape not just two galaxies, but the entire local group. The speculative horizon is not limited to matter and mergers. It extends to perception itself. The Milky Way is the galaxy we inhabit, yet our view of it is incomplete. Dust blinds us. Distance diminishes us. Perspective confines us. To misjudge its size is to confront the limits of our knowledge. If we cannot see our own galaxy clearly, how much less can we know of the universe beyond? Perhaps the galaxies we map, the filaments we trace, the cosmic web we sketch, are all as incomplete as our early maps of the Milky Way, fragments awaiting correction by deeper vision. This humility is not defeat, but revelation. Science thrives on the edge of the unknown. Each miscalculation is a door, each surprise a path. Theories about the Milky Way's size and shape are not final truths, but scaffolds, temporary structures built to support the climb toward clarity. And as each scaffold falls, the galaxy grows larger, stranger, and more profound. The deeper the speculation turns, the more the Milky Way becomes a mirror of cosmic law itself. For at its core, the galaxy is not only an accumulation of stars and dark matter, it is a theater where the very fabric of space-time is bent, curved, and revealed. Einstein's general relativity reshaped how astronomers perceive the Milky Way's motions. No longer is gravity imagined as a force acting at a distance. Instead, the galaxy exists as a depression in space-time itself, a colossal valley carved by mass into which stars fall along curved paths. At the center of this stage lies Sagittarius A, the supermassive black hole. 4 million times the mass of the Sun, it is invisible, yet it rules the core with unrelenting gravity. For decades, its presence was inferred indirectly. But in recent years, the orbits of stars known as S-stars have traced its dominion with breathtaking clarity. 1, S2, completes its ellipse in just 16 years, swinging close enough to reveal the warping of space-time in real time. In 2018, astronomers confirmed that S2's light shifted as Einstein predicted, reddened by the immense gravity of Sagittarius A Psi. The implications extend far beyond the center. The Milky Way's black hole is not an isolated singularity. It is the anchor of the galaxy itself. Some theories suggest that the stability of the inner disk, even the very growth of the galaxy, may be tied to its gravitational heart. Stephen Hawking once speculated that black holes were not only destroyers, but engines of structure. They consume, yes, but they also organize, shaping the cosmos through their irresistible pull. If so, then the Milky Way ES scale and form are not merely the product of mergers and dark matter. They are also sculpted by the singularity at its heart. And yet, Sagittarius A is modest compared to the giants in other galaxies. Some harbor black holes billions of solar masses in weight, their influence stretching across tens of thousands of light years. If the Milky Way's central black hole were larger, would the galaxy itself have grown differently? Would its spiral arms extend farther, its halo swell greater? Or is its current size a balance, the outcome of billions of years of delicate gravitational interplay? Such speculation reveals the interdependence of scales. A black hole no larger than a pinprick in our maps may dictate the outline of the galaxy entire. Beyond the center, relativity deepens the enigma of dark matter. If space-time is curved by mass, then the unseen halo is not simply invisible. It is a distortion of the universe itself. To measure its shape is to measure the curvature of space-time on scales beyond comprehension. If the halo is spherical, space-time curves symmetrically around us. If triaxial, it bends unevenly, stretching and compressing the galaxy's geometry. If clumpy, it creates ripples, subtle warps in the fabric that guide the orbits of stars. In this sense, the Milky Way is not only larger than imagined, it is stranger, a distorted valley in the universe whose true contours we have only begun to trace. Speculation stretches to hidden actors as well. Intermediate mass black holes, born of collapsed star clusters or ancient galactic cores, may drift in the halo. Their existence is uncertain, but their possibility tantalizes. If they are there, their subtle gravitational fields may explain anomalies in stellar streams, their unseen presence reshaping the very map of the galaxy. Each one would be a dark island, invisible yet immense, lost in the galactic sea. And beyond black holes lies the philosophical horizon. Perhaps the Milky Way has no true boundary at all. Its halo fades gradually, its corona blends into the intergalactic medium, and its dark matter stretches into filaments that connect to other galaxies. In cosmology, galaxies are not islands but nodes, knots in a cosmic web woven of dark matter and gas. The Milky Way's size, then, may be an illusion. It is not a separate entity, but a condensation in a larger structure that spans the universe. To speak of edges is to impose a human need for borders onto a reality that has none. This realization forces a deeper humility. For centuries, humans imagined the Milky Way as the universe itself. Then it became one galaxy among many. Now, even as we map its stars, it dissolves again into halos, into filaments, into webs without end. Each revelation is a reduction of certainty, a reminder that our definitions are scaffolds built on shifting ground. Philosophy bends close to science here. If we misjudge the size of our own galaxy, what else remains misjudged? Are the great cosmic filaments larger than we imagine? Are the voids emptier, or filled with matter too diffuse to see? The Milky Way, this mystery, becomes a symbol of perception itself. A truth always larger than our view, always receding into the dark. In this light, the galaxy is not just a home. It is a question whose answer grows with every discovery, yet never resolves. Einstein's equations explain its curvature. Hawking's insights remind us of its paradoxes, but neither offers closure. The Milky Way remains bigger, stranger, more profound than thought. And perhaps that is the point. Perhaps galaxies, like the universe, are not meant to be bounded in definition, but pursued in wonder. Speculation about the Milky Way does not stop at what it is. It stretches into what it will become. Every galaxy is a story written across time, and the Milky Way's future is one of collision, transformation, and rebirth. 4 billion years from now, the Andromeda Galaxy will loom large in the night sky. At first, it will appear as a faint blur, gradually swelling until it dominates the heavens, an approaching tide of starlight. Already their halos are overlapping, their dark matter domains interwoven. The merger has, in some sense, begun. When the two galaxies finally meet, it will not be a violent crash of stars. The distances between suns are too great. Instead, their disks will interpenetrate like ghostly phantoms. Spiral arms will distort, stretching into tidal tails that arc across intergalactic space. Clouds of gas will collide, compressing into bursts of new star formation, galactic fireworks on a scale beyond imagination. Over billions of years, the spirals will dissolve, their identities erased. What remains will be a single massive elliptical galaxy, luminous and swollen, its stars moving in random orbits rather than orderly spirals. Astronomers have named it Milky Way. Speculation asks, if the Milky Way is larger than once thought, how does that reshape this fate? A heavier halo pulls with stronger gravity. A broader disk collides with greater reach. The timeline may shift. The union may begin sooner. Already the Sun, circling the galactic center every 225 million years, is part of a trajectory that cannot escape this future. In 4 billion years, its orbit will carry it through a galaxy that no longer resembles the one it began in. But the Andromeda merger is not the only horizon. The local group itself, a collection of 50 or more galaxies bound together, may be redefined by the Milky Way, ES true size. If its halo is vast enough, then its reach extends into the space between galaxies, binding companions like Triangulum more tightly than expected. On even longer timescales, the local group will merge with the Virgo cluster, forming a still larger structure. The Milky Way's fate is thus a chain reaction, its size shaping not only its own destiny, but the architecture of the cosmos around it. Yet perhaps the most profound speculation is that the Milky Way never truly ends. Its luminous disk, its halo of stars, its dark matter cocoon, its hot corona, each layer blends into something larger. Beyond the halo lies the cosmic web, the filaments of dark matter that span the universe like threads of an immense tapestry. The Milky Way is not an island floating in emptiness. It is a knot in this web connected invisibly to structures millions of light years away. To ask where it ends may be to ask the wrong question. Perhaps it does not end at all. This idea is unsettling, for it means that what we call the Milky Way is not a bounded object, but a perspective, a vantage point within a continuum. The boundaries we draw are conveniences of human thought, not features of the universe itself. In reality, the galaxy bleeds into the larger structure of the cosmos, as surely as continents bleed into oceans. Its scale is elastic, defined not by nature, but by need. Here lies a philosophical revelation. Every step in our history of discovery has been an act of reduction. First, the Milky Way was the universe itself. Then it became one among many galaxies. Now it dissolves further into halos, filaments, and webs. Each correction diminishes our sense of centrality, but expands our sense of belonging. The Milky Way is not a bounded kingdom. It is part of a cosmic republic, one strand in a fabric whose vastness we cannot yet comprehend. Speculation even reaches inward, to the level of perception. The phrase "bigger than we thought" may be less about the galaxy than about the mind. Our measurements, our models, our telescopes, each is an extension of perception. Each expands the horizon. But the galaxy itself does not grow. It was always this vast, always this strange. What grows is our awareness. What expands is our willingness to let go of certainty. The Milky Way becomes not only an object of study, but a lesson that the universe is always more than we believe. Einstein's equations whisper that even space and time themselves are mutable. Hawking's reflections remind us that singularities guard mysteries deeper than comprehension. The Milky Way, with its warped disk, its invisible halo, its cannibalistic history, and its uncertain boundaries, is both laboratory and symbol. It is the place where human reason confronts the vastness of reality and finds itself humbled. In the end, perhaps the greatest speculation is not about the Milky Way's mass or shape, but about meaning. What does it mean to live inside something so immense that its edges dissolve into infinity? What does it mean to measure a home that can never be fully mapped? To dwell in a galaxy that is both cradle and labyrinth, both luminous and dark? The answer may be that it means nothing and everything. Nothing because the galaxy does not shape itself to human significance. Everything because in trying to understand it, we glimpse the essence of science, the pursuit of truth beyond perception, the embrace of wonder in the face of immensity. The Milky Way is bigger than we thought, but perhaps that phrase is only the beginning. Perhaps the truth is that size itself is an illusion, a boundary we invent for comfort. In the cosmos, there may be no edges, no ends, only horizons that recede as we advance. And so the Milky Way remains what it has always been, a mystery, luminous and invisible, finite and infinite, a reminder that the universe is not made to be contained, but to be discovered again and again. To trace the true shape of the Milky Way, astronomers have had to build instruments capable of peeling back the veils of dust, distance, and time. Each tool is not only a machine, but a new sense, an extension of human perception into realms where the eye alone is blind. The investigation of our galaxy has become less a question of looking and more a question of constructing vision. The first revolution came from space itself. The Hubble Space Telescope, launched in 1990, revealed a universe beyond what ground-based observatories could see. By escaping Earth's atmosphere, Hubble captured crisp images of distant galaxies, quasars, and nebulae, offering context to the Milky Way by comparison. But even Hubble could not map the galaxy from within. Its strength was in deep focus, not breadth. The Milky Way demanded something else, a census of stars. That census began with Gaia. Launched in 2013 by the European Space Agency, Gaia became the cartographer of the galaxy. By measuring the positions, motions, and brightness of more than 1 billion stars, Gaia created the most detailed 3D map ever attempted. Its precision is astonishing. For some stars, it can measure shifts in positions smaller than the width of a human hair seen from 1,000 kilometers away. This accuracy allows astronomers to trace stellar streams across the halo, to reconstruct the orbits of globular clusters, and to detect the fossils of galaxies consumed long ago. Gaia has transformed the Milky Way from a flat picture into a living, dynamic system, where each star is a data point in motion. But Gaia is only one eye among many. Radio astronomy has become indispensable in piercing the Milky Way's hidden depths. Neutral hydrogen, emitting its 21-centimeter signal, has been mapped across the sky by arrays such as the Very Large Array in New Mexico and the Parkes Observatory in Australia. These surveys reveal the spiral arms invisible to optical light, as well as the Magellanic Stream, a vast ribbon of gas stretching from the Magellanic Clouds, evidence of their ongoing interaction with the Milky Way. Radio telescopes also trace pulsars, whose rhythmic beacons serve as galactic lighthouses, marking distances and motions with exquisite precision. Infrared observatories have added another dimension. NASA's Spitzer Space Telescope, operating until 2020, peered through the dust clouds that obscure the galactic center, revealing stars and structures otherwise hidden. Its successor, the James Webb Space Telescope, though often celebrated for its views of the distant universe, also turns its gaze inward, resolving star-forming regions in unprecedented detail. These instruments remind us that to know the Milky Way, one must see it in every wavelength, for each reveals a different layer of truth. On the ground, spectroscopic surveys such as APO-G, Apache Point Observatory Galactic Evolution Experiment, and LAMOST, Large Sky Area Multi-Object Fiber Spectroscopic Telescope in China, analyze the chemical fingerprints of stars. Every star carries in its light the record of its birth, encoded in the abundance of elements within it. By studying these fingerprints, astronomers reconstruct the history of galactic mergers, identifying populations of stars born in other galaxies and later absorbed. The Milky Way's halo is no longer seen as a uniform fog, but as a mosaic of immigrant stars, each carrying the memory of its origin. Beyond telescopes, simulations have become crucial. Supercomputers now recreate galaxies under the laws of physics, testing how dark matter, gas, and stars interact across billions of years. Projects like Illustris, Eagle, and Fire simulate entire universes where galaxies grow, merge, and warp under cosmic conditions. When compared with real observations, these simulations reveal whether our models of gravity, dark matter, and star formation align with reality. In many cases they do, but in others they diverge, pointing toward unknown physics still to be uncovered. Gravitational wave observatories such as LIGO and Virgo extend the search into new realms. Though designed to detect the collisions of black holes and neutron stars, they also hint at the Milky Way's hidden population of remnants. Each ripple in space-time that passes through Earth is a reminder that our galaxy contains countless objects unseen, each one shaping its mass and future. In coming decades, the planned space-based observatory LISA, Laser Interferometer Space Antenna, will tune to lower frequencies, capable of detecting the slow-in spirals of massive black holes, including perhaps signals from the merging of Sagittarius A with other black holes drawn into its orbit. Even the cosmic microwave background, the faint afterglow of the Big Bang, plays a role in understanding the Milky Way. By studying how the galaxy's halo scatters this radiation, astronomers infer the properties of the hot corona surrounding it. The echoes of the universe's birth, filtered through our galaxy, tell us about the boundaries of the Milky Way itself. Each tool, Gaia, Hubble, Webb, APOG, radio arrays, gravitational detectors, offers a different slice of truth. None is complete, but together they form a symphony of instruments, each note refining the image of the galaxy. The process is ongoing. Every new survey reveals anomalies that demand explanation. Every anomaly reshapes the models. The Milky Way is not only bigger than we thought, it is more complex than we can yet define. Future missions promise even deeper vision. The Vera C. Rubin Observatory in Chile, with its Legacy Survey of Space and Time, LSST, will capture the entire southern sky repeatedly, detecting faint satellites, tidal streams, and variable stars. NASA's Roman Space Telescope will map the sky in infrared with wide-field precision, complementing Gaia and Webb. Together, they may uncover the faintest companions of the Milky Way, the hidden arms, and perhaps even the elusive dark matter subhalos predicted by theory. But each tool also carries a humbling truth. The more we observe, the less certain our boundaries become. Gaia reveals stars farther than expected. Radio telescopes uncover streams stretching beyond the disk. Simulations predict halos larger than our instruments can confirm. The pursuit of clarity only multiplies the shadows, and so the investigation remains unfinished. The Milky Way is still being tested, still being weighed, still being mapped. Every new tool brings us closer, yet also farther, for with each discovery, the galaxy grows beyond its former outline. The task is endless, not because science fails, but because reality is inexhaustible. The galaxy we call home is not a static object to be measured once and defined forever. It is a living system, unfolding in time, reshaped by collisions, expanded by unseen matter, bounded only by influence that fades into infinity. The instruments of humanity, from glass lenses to spaceborne observatories, are not closing the case. They are opening it wider, showing us that the Milky Way is bigger, stranger, and more profound than even speculation allowed. The Milky Way has revealed itself as vast beyond measure, larger in mass, broader in influence, stranger in structure than humanity once believed. Yet the deeper truth lies not only in its size, but in what that revelation means. For every new map of the galaxy is also a map of perception itself. To misjudge our home is to confront the limits of human certainty. To expand its borders is to expand our awareness of how small we are and how boundless the universe is. The galaxy has long been a mirror of human imagination. In ancient myths, it was the milk of gods, the road of souls, the scar of creation. In early science, it became a disk of stars, finite and fragile. Today, it dissolves into halos and filaments, dark matter and streams, with edges that fade into invisibility. Each version was true in its time, and each was incomplete. The Milky Way changes not because the galaxy alters, but because human vision deepens. It was always this vast, this strange. Only our understanding was small. In this lies a paradox. The Milky Way is both intimate and immense. It is the sky we see every night, the soft river of starlight crossing the darkness. And yet it is a structure so vast that even light takes 100,000 years to cross its luminous disk, and perhaps 1,000,000 to traverse its invisible halo. We live inside something that dwarfs comprehension, yet we perceive it as a band of light, a familiar arc overhead. Our home is both near and unreachable, both cradle and labyrinth. The emotional weight of this realization is profound. To live inside a galaxy is to live inside history. Each star we see is a record of billions of years, each cluster a remnant of collisions, each stream a scar of cosmic cannibalism. Our very atoms were forged in generations of stars that lived and died within this spiral. The Milky Way is not only our environment, it is our ancestor. The iron in our blood, the oxygen we breathe, the carbon that forms our bodies, all were created in stars that once burned in the arms of this galaxy. We are not observers standing apart. We are participants, products of its cycles, children of its fire. And yet, even as it nurtured life, the galaxy remains indifferent. It does not bend itself to human meaning. Its stars circle their orbits, heedless of our questions. Its halo extends invisibly, regardless of whether we measure it. Its dark matter enfolds us in silence, never revealing its nature. In this indifference lies both humility and freedom. The Milky Way reminds us that existence is not designed for us, and so the meaning we find must be our own. Philosophically, the phrase, "bigger than we thought," becomes more than description. It becomes reflection. For the galaxy is not the only thing misjudged. Throughout history, humanity has underestimated the universe at every scale. We thought Earth was the center. We thought the sun was unique. We thought the Milky Way was the universe. Each time we discovered that reality was larger, stranger, more complex. The Milky Way's expansion in our minds is part of this pattern. It is a lesson written in stars that the cosmos will always exceed imagination. Even science itself is humbled by this truth. Our instruments grow sharper, our models more precise, yet the boundaries slip away. Define the Milky Way by its stars, and new ones are found beyond the disk. Define it by its halo, and simulations predict greater extents. Define it by gravity, and its influence stretches into the local group. At each step, the galaxy eludes containment. Perhaps it cannot be bounded at all. Perhaps its size is not a fixed number, but a horizon, receding as we pursue it, like a shoreline that vanishes as we approach. The Milky Way thus becomes a metaphor for knowledge itself. Each discovery enlarges not only the galaxy, but the unknown around it. The more we learn, the more vastness remains. This is not defeat, but wonder, for it means that the cosmos is inexhaustible, that there will always be horizons to chase, mysteries to unfold, questions to ignite the imagination. The galaxy is both object of study and symbol of unending curiosity. Emotionally, this realization stirs awe. To step outside under the night sky is to stand within a cathedral whose architecture is invisible yet immense. The arc of the Milky Way above us is the faintest hint of its true expanse. The stars we see are not the edge, but the beginning. Beyond them lie clusters, streams, halos, dark matter, and filaments stretching into infinity. To gaze upward is to gaze into immensity, and to feel both small and vast at once. Small because our lives are brief, our reach limited. Vast because we are part of this structure, woven from its elements, carried within its arms. In the end, perhaps the most profound reflection is this: the Milky Way was never meant to be measured in light years alone. Its true magnitude lies in what it awakens in those who contemplate it. It is a reminder that we live in mystery, that the boundaries of knowledge are always temporary, that humility and wonder are the twin gifts of science. The galaxy is bigger than we thought, but perhaps bigger is the wrong word, wrong. Perhaps it is not size that matters, but depth. Depth of time, depth of complexity, depth of meaning. The Milky Way is not simply a place. It is a journey, an invitation to look outward and inward, to see the universe and the self reflected in a single river of stars. As the night sky turns, the band of the Milky Way stretches above. It is the same light seen by ancient eyes, the same arc traced by myth and story. And yet for us it is also a frontier, mapped, measured, and still unbounded. The galaxy does not shrink to our understanding. It expands, waiting for us to follow.